Determine whether this Boolean expression is true or false. We may need to apply some of these Boolean algebra identities, so I have it over here, this list, as a handy reference. Okay, first step. Let's just follow the order of operations and simplify the arithmetic wherever we can. Please excuse my dear Aunt Sally. I'm going to do the parentheses first. And I look at the parentheses here. And within the parentheses, I am going to do any multiplication that I have and division from left to right. So I see I have this 9 times 8. That simplifies to 72. I should rewrite this whole thing as a step, but I'll do a couple steps at a time here in this video. Okay, over here I have some multiplication. 9 times 6 is 54. And this multiplication here is 6. Okay, now I'm rewriting everything. 3 greater than, 8 minus, that 3 times 2 became 6. I rewrite the and the not. I rewrite this left parenthesis, of course. I rewrite the greater than sign, 7 plus 9 times the 6 became the 54. Rewriting or 9 not equal to 8 plus 1. Okay, I finished multiplication and there is no division. So I'm now going to do any addition and subtraction, which are tie, and I do them from left to right. So over here, actually changing colors to make it easier to follow, that 8 minus 6 becomes 2. 7 plus 54, 61. 8 plus 1 is 9. There's nothing else as far as addition or subtraction to do. So I'm going to rewrite everything else. 3 greater than, the and the not need to be rewritten. This parenthesis needs to be rewritten. And I now I ran out of room for the 72, so I'm going to erase a little bit, move that 61 over. So I have a 72 greater than or equal to the 61, the word or, and then this 9 is really the same. Okay, I'll move over the 9 of the 8 plus the 1. And this 9 is rewritten as a 9. The not equal to symbol is still there. Right parenthesis, and that is the complete third step. Okay, the next step. I'm finished with additions and subtractions, and of course multiplications and divisions. So now we work out the relational operators. The greater than symbol, the greater than or equal to, the less than or equal to, and any not equal to's, and any simple equal to's. These are all tie, and they would evaluate from left to right. So 3 greater than 2. In the world of Boolean algebra, 3 greater than 2 simplifies, you can either think of it as the word true, or the number 1, or just the t. I'm going to write out the word true to make this very clear and easy to follow. Okay, I rewrite the and the not and the parentheses. Okay, this relational operator, greater than or equal to. I ask myself, is 72 greater than or equal to 61? That is true. So all of that simply becomes true. And I rewrite the or, and now I ask myself, is 9 not equal to 9? Think about it. That would be false, because 9 is indeed equal to 9. And saying that they're not equal is a false statement. So that became that, and don't forget this originally became the true. Okay, my next step, working these parentheses. When you have an or between a true and a false, if you've ever had me explain to you how a truth table works with zeros and ones for two variables a and b, this true is sort of like the left-hand operator a. The false is sort of stored in the right-hand operator B with the or in between. So that would be on this chart that I call the truth table, that would be somewhere where we have a true ORed with a false. And I'm going to ignore the AND column of my normal truth table and just focus on the OR column, which looks like this. So if you have a true ORed with a false, the simplification is a 1, or in other words, a true. So A or B, true. If somebody says you can have dessert if you eat asparagus or broccoli, and they say the word or, and if you did indeed eat asparagus, doesn't matter whether you ate broccoli or not, because you are guaranteed to get dessert as long as you eat one or the other, or both. So true is the simplification of A or B, where true is being ORed with false. Okay, rewriting everything else, moving into this step, we have the original true up there, the original and the word not. Now this set of parentheses is still there. It's around the true. And when you have the not operator, the not of followed by a set of parentheses with the true, that simplifies to the opposite of true. And the opposite of true is false. So we have now simplified this step into false. I rewrite everything else, the true and the and. Okay, that leaves us with the analysis of, again, a true and with a false, but we need to know what the and is. If somebody says you can have dessert if you eat your asparagus and your broccoli. But if you don't eat your broccoli, and if that's false, then you don't get dessert. In other words, the answer is false or 0. And in this exercise, since they are specifically telling us to write our answer as either true or false, I am not writing it as a 0. Instead, I'm writing the final answer as false. All of these steps were equivalent to this original long, messy expression, but the answer is simply false for this exercise.